Hello everyone. In this video we will continue with the elementary integration standard formulas. We have already seen in last video four standard formulas. What are those? The four standard formulas are integration of x की power n dx, okay, that is x की power n plus 1 by n plus 1, and of course plus c, but n should not be equal to minus 1. Second we saw that is 1 upon x का dx. This is log of mod of x plus c. Third one is integration of e की power x का dx. This is e की power x plus c. And fourth one is a की power x का dx, that is a की power x divided by log a and of course plus c. So these four standard formulas we have already seen in the last video, correct? And we have solved some problems on the basis of these four standard formulas. Now we will continue to develop some other standard formulas on the basis of our knowledge in differentiation. Okay. So come to the trigonometry now. The fifth one is the integration of sin x का dx, that is equal to minus का cos x plus का c, correct? Why? Because derivative of minus cos x is equal to sin x, correct? So also we can transfer it in the linear function, that is the integration of sine of ax plus ka b dx, that will be minus of cos of ax plus b divided by a. That we know that how the integration formulas are valid when there is a linear transformation of the function, correct? Sixth one is integration of cos x ka dx, that is sine of x plus ka c. Seventh one is integration of sec square x ka dx, that is equal to tan x plus c. The reason is very simple. The derivative of tan x is sec square x. Therefore, integration of sec square x is tan x. Okay. The derivative of sin x is cos x. Therefore, integration of cos x is sin x. That is very simple because integration is the reverse process of differentiation. Correct. And we all know that the differentiation derivative of tan x is sec square x. Or like that, the integration of cosec square x dx, that is equal to minus का cot x plus का c. Ninth, integration of sec x tan x का dx is integration of sec x tan x dx is sec x plus c. And the tenth one is, okay, tenth one, integration of cosec x into cot x dx is minus का cosec x plus c. So these formulas we have on the basis of our basic knowledge of differentiation. The derivative of sec x is sec x tan x. Therefore, integration of sec x tan x is sec x. The derivative of cosec x or minus cosec x, directly you can say that. The derivative of minus cosec x is cosec x cot x. In fact, the derivative of cosec x is minus of cosec x into cot x. Therefore, minus of cosec x का derivative is cosec x into cot x. Therefore, the integration of cosec x into cot x dx, that is equal to minus का cosec x plus c. And this type of linear transformation we can do in every formula, correct? Okay, now coming to the next formulas. Okay, we have now come to the 10th one, correct? Okay. Now coming to the three more standard formulas, that is 11th one. 11th one is integration of 1 upon square root of 1 minus x square dx, that is equal to sine inverse of x and of course plus c. Now look at here. The differentiation of sine inverse x is 1 upon square root of 1 minus x square. But in inverse trigonometry we know that the pi by 2 is equal to sine inverse x plus cos inverse x. So therefore sine inverse x can be written as pi by 2 minus ka cos inverse x plus ka c. This is constant, this is also constant, so that will give another constant. Therefore this formula is also minus cos inverse of x plus c. Correct? So the integration of, you can say that the integration of square root of 1 upon square root of 1 minus x square is sine inverse x plus c or minus cos inverse x plus c. Okay, come to the 12th one. Integration of 1 upon 1 plus x square ka dx. That is equal to tan inverse of x, because tan inverse x derivative is 1 upon 1 plus x ka square. Correct? And of course plus c. And by using the similar argument with the inverse trigonometric function, this can be written as minus of cot inverse of x plus c, because tan inverse x is pi by 2 minus of cot inverse x, and that pi by 2 will combine with this constant, gives the new constant. Correct? And the 13th one, that is integration of 1 upon mod of x of square root of x square minus 1 dx. That is equal to sec inverse of x plus c, and that is equal to minus of cosec inverse of x plus c. So these formulas are very much clear now, because we know the differentiation. I know the differentiation of sine inverse x. Correct? I know the differentiation of tan inverse x, and I know the differentiation of sec inverse x, and because of that we can develop this integrations formula, because integration is a reverse process of differentiation, and therefore we call it as elementary integrations or the standard formulas. So what happens in the integration process, there are the functions which you have to integrate, but those integrations you cannot find out directly because you don't know their differentiation, the function whose differentiation is that particular integrand. Correct? So because of that we have to do the process like transformation, like substitution, so that the given integrations converted into these standard integration. This is the whole process we will apply throughout the chapter integration, indefinite integration. Okay, we have to convert those functions integrations into the known functions integration. That is the standard formula. So because of that you have to remember all these standard formula first. Now how to convert those functions integrations into the known functions integration, that is the standard formula. That is the different thing, that is the method of integration. There are basically three methods, that is the method of substitution, method of transformation, and method of integration by parts. So first of all you should remember all these three, all these 13 standard formulas. Let's do some problem on these basic elementary integrations. So what is the integration of, tell me, now it's your turn. What is the integration of sine ka 2x ka dx? Definitely minus ka cos 2x divided by 2 plus c. First. Second one is integration of sec ka square 4x minus 5 ka dx. Sec square x integration is tan x. So tan of 4x minus 5, 4 divided by, and of course plus c. Correct? Very simple. Now similarly find the integration of sin x function, sin x with respect to sec x. Correct? Now this is what integration of sin x, but not with respect to x, but with respect to sec x. This is very interesting. Already we have gone through such type of problems in the last video. So therefore sin x. And what is the differential of sec x? Sec x tan x. Sec x tan x. And then dx. Correct? Now I can differentiate. Sec x is 1 upon cos x. So tan square x, this will be integration of tan square x ka dx. See, I cannot integrate the tan square x function because we don't know the differentiation whose differentiation is tan square x. We have to convert it. Now we have to convert it. We have to transport it. We have to apply the transformation so that I can easily integrate this function by our elementary integration. That is the standard formula. So I don't know the integration of tan square x function, but I know the integration of sec square x function. Therefore, I can write it as a sec square of x minus 1 ka dx. This is important. Okay. Now, these are the standard formulas. That is integration of sec square x ka dx minus integration of 1 ka dx. Sec square x means integration sec square x dx means tan x, because tan x ka derivative is sec square x, and this is 1 dx. This is your answer. Correct? I hope that everyone can understand this problem now. Coming to the fourth one. Okay. Fourth one is again find the integration or antiderivative. Antiderivative of cos cube x with respect to tan x. ठीक है, cos cube x with respect to tan x. ये कैसे होगा? This is also the same process. We have to integrate cos cube x, but not with respect to x, with respect to tan x. Okay, so therefore we have to first of all find out this d of tan x, that is differential of tan x. So this is what cos ka cube x, differential of tan x is sec square x and dx. So this is simply cos x ka dx, no? And that is simply sine of x plus ka c. Correct? Okay. This problem is over. If suppose that I want to do the integration of sine of x degree with respect to dx. So the variable is x over here, but here it is x ka degree. So what to do now? This is not like that, minus cos of x ka degree plus c, not like that. Correct? So first of all, we have to convert this x ka degree in the radian. We know that 180 degree is equal to pi radian. Correct? So therefore, x degree equal to pi by 180 into x. So therefore, I can write it sine of pi by 180 into x ka dx. Now I can apply the standard formula. That is what? Cos of minus cos of pi by 180 of x, and the coefficient of x must be in denominator 180, and of course plus ka c. So this is your answer. Correct? One more question on this concept. Last question that will be in this video. Okay. What is the integration of sec x degree into tan of x degree dx? Correct. Now, this is also the integration variable is x, but these are the function in x ka degree. So first of all, we have to convert this. Similar fashion, the x degree is pi by 180 ka x. So therefore, this is what? Sec of pi by 180 ka x into tan of pi by 180 का x into dx. Correct? Fine. इसको ऐसे कर दो. So now sec x tan x का integration is what? Sec x, ना? So therefore this is sec of x, that is pi by 180 का x divided by pi by 180. This pi by 180 can be written as 180 by pi, and of course plus ka c. This is your answer. So I hope that now you have understand the elementary integrations, and this standard integrations we have find out by using the knowledge of basic knowledge of differentiation. But there are certain functions also which we have to integrate, and that integration is not easily possible because you don't know easily the function whose differentiation is that integrand. So because of that, all those methods, that is the method of transformation, okay, method of substitution, bypass integration, all these methods will help you to find out the integration. For example, I have already explained how to find out the integration of tan square x का dx. This is transferred to sec square x by sec square x minus 1 का dx by our basic knowledge of differentiation as well as the trigonometry. I know that I can easily find out the integration of sec square x and minus 1. Correct है ना? Okay. And by the trigonometry, I know that the 1 plus tan square x equal to sec square x. Therefore, tan square x is sec square x minus 1. So, the tan square x का integration I know that is what? Tan x. Minus 1 का integration I know that is minus x, and of course plus c. So, this is the way I have transferred this integration tan inverse tan square x का dx into the integration of sec square x minus 1. So, on the basis of your knowledge, what you have learned so far, okay, that you have to apply to find out the integration of other functions. Okay, we have gone through the 13 standard formulas. Okay, these 13 formulas are will help you to find out the integration of all those functions. Okay, like that, the integration of tan square x, integration of tan cube x, integration of cos cube x, and all those things you can now easily find out by transforming those integration into the known integration by using your basic knowledge, like the knowledge of trigonometry, correct hai? Knowledge of algebraic identities, and like that. For example, here we have transferred these integration into this one because of our knowledge that this 180 degree equal to pi. So I can convert this x degree into radian, that is in x. Now whenever x is there and dx is there, therefore now I can integrate it and I can apply the standard formulas. So I hope that you understand all these standard formulas. This is all about this lecture.